Welcome to The Explainer. So today we're talking about large language models. Look, we all know they're everywhere right now. They get some things amazingly right and other things, well, very, very interestingly wrong. If you've ever used one and thought, wait, where did it even get that information? You are definitely not alone. Okay, let's dive into this, because today we're exploring a specific framework designed to fix this exact issue. It's called RAG, and it's absolutely all about fixing AI's memory problem.
To really understand how AI behaves, let's start with a surprisingly simple analogy. Imagine a kid walks up to you and asks this exact space trivia question. In our solar system, what planet has the most moons? Now, if you're kind of like me, or actually like Marina Daniilewski, she's a senior research scientist at IBM Research who originally shared this great little anecdote, you might get pretty excited. You're thinking, oh, I loved space when I was a kid. I know this one.
And relying purely on your memory, you might confidently declare, it's Jupiter with 88 moons. You read it in an article once, so it must be true, right? Well, maybe 30 years ago. Compare that to what happens if you take a beat, pause, and check a reputable source like NASA first. You'd quickly find the grounded, researched answer. It's actually Saturn with 146 moons. The science changed, but your memory, it didn't.
Section 1. Two major LLM challenges and why relying on memory isn't enough. And this brilliantly illustrates exactly what goes wrong with standard large language models, or LLMs. When you ask a standard generative AI a question, it acts just like that overconfident adult relying on decades-old memories. It dives into the parameters it learned during its initial training, and it just spits out an answer. It thinks it knows the facts, but relying solely on memory just isn't enough.
Which brings us to two major inherent limitations of standard generative AI models. Number one, there is absolutely no source to support the claim. Just like giving an answer off the top of your head, the AI isn't citing anything. It's really just generating text based on probabilities. And number two, the information is often out of date. The world keeps moving forward, right? Scientists discover more moons, but the AI's training data is completely frozen in time at the exact moment it was created. These are the two major hurdles engineers have literally been racing to solve.
Section 2. The RAG solution, adding a content store to generative AI. So how do we fix an AI that is overconfident, unsourced, and out of date? Well, researchers have designed a brilliant framework to solve these exact challenges and bring real, verifiable accuracy to these models. It's not about throwing the AI away. It's about fundamentally changing how it fetches its information.
Enter RAG. This stands for Retrieval-Augmented Generation. It's a framework that helps large language models be more accurate and up-to-date by fetching relevant info from an external content store before generating an answer. Let's break that down just a bit. The generation part, that's the AI model we already know, the part that effortlessly writes the text. But the retrieval-augmented part, that is the absolute game changer.
Retrieval basically means we are giving the AI a reference library. We're connecting the LLM to a content store. Now, this could be the wide-open internet, or it could be a highly secure, closed collection of internal corporate documents and policies. The whole point is, instead of the AI just blurting out the first thing it remembers from its training days, it acts like a person pausing to check the NASA website for facts. It talks to the content store first and asks, hey, can you retrieve any information relevant to what this user is asking?
Section 3. Inside the RAG prompt, changing the instructions. Let's move to and see how this builds a system where we actually make the AI work smarter, not just harder.
In a normal setup, a user asks a question, and the model just fires back an answer. Boom! But inside the RAG framework, the prompt is transformed into a strict three-step process. Step 1. The model is essentially instructed, no, don't just answer yet. First, go retrieve relevant content from our data store. Step 2. Take that newly retrieved content and combine it with the user's original question. And Step 3. Now, and only now, generate the answer using that combined information. By forcing the model to use this external evidence, we completely stop it from just relying on what it happened to memorize during its initial training.
Section 4. Why RAG matters. Fixing the two main challenges. So why does this specific three-step sequence matter so much? Let's circle back to those two massive problems we talked about at the very beginning of this explainer: the out-of-date memory and the lack of sources. RAG practically solves both of them in incredibly elegant ways.
First, let's look at the out-of-date problem. Look, retraining a massive large language model from scratch takes immense amounts of time, money, and computing power. You do not want to do that every single time astronomers find a new moon around Jupiter or Saturn. With RAG, you simply don't have to. You just augment the external data store with the new information. You're basically just updating your library.
The next time a user asks a question, the model retrieves the newly updated document and instantly provides the correct current answer. No retraining required at all.
Next is the sourcing problem. By instructing the model to pay attention to primary source data, it becomes significantly less likely to hallucinate. We all know hallucination. It's that super frustrating moment when an AI confidently just makes things up. But when it's forced to base its answer on the retrieved document, it's actually grounded in reality. It can literally point to the evidence and say, here is exactly why I'm giving you this answer. Plus, this prevents the AI from leaking weird personal data or going off on strange tangents drawn from its massive unfiltered training history.
Section 5. The power of admitting ignorance. A new paradigm for AI. Now, what's really interesting about this slide is a behavioral change in the AI that is surprisingly positive and honestly, deeply human.
Standard AI responses hate dead air. So, when a model doesn't know something, it just hallucinates, fabricating a highly believable but completely false and potentially misleading answer. But because the RAG-enabled model is explicitly instructed to rely only on the retrieved data, something amazing happens. If the data store lacks the answer, the model will gracefully admit, I don't know. I mean, think about that. This power to simply admit ignorance is a massive, massive leap forward for AI reliability.
Section 6. The catch. Quality retrieval. Of course, as with any incredible technological leap, there's always a catch. RAG is a brilliant framework, for sure, but it's not magic. This entire beautiful system depends heavily on the quality of one very specific component in the chain.
And that component is the retriever itself. The generative AI, the part writing the final text, can only give a high-quality, grounded response if the retrieval mechanism successfully fetches the right information first. If your retriever is poorly designed, or maybe your data store is just a complete mess, the whole system breaks down. If the retriever is not sufficiently good, a perfectly answerable query might not get an answer at all, or honestly, worse, it might retrieve irrelevant junk, leading to a really confusing or just poor final response.
This creates a real dual-sided challenge for the tech industry. As Marina Danielewski from IBM Research points out, we are both working to improve the retriever and also the generative part so that the LLM can give the richest, best response finally to the user. It's essentially a two-front effort. Companies are constantly refining the search algorithms that pull the data while simultaneously polishing up the language models that read and summarize that data.
So, the crucial point is, we are steadily moving away from AI as this mysterious oracle that just guesses the truth from its murky memory, and moving towards AI as a meticulous researcher that actually checks its facts before speaking. As AI learns to cite its sources and, perhaps more importantly, gracefully say I don't know when it genuinely lacks the data, how will this grounded approach change the way we trust technology in our everyday lives? It's a fascinating shift, and it leaves us with a whole lot to think about as we interact with these tools going forward. Thanks for joining me on this explainer. I'll catch you next time.